let me go to this. What I'm getting these from is I'm getting these from the CPM ebook, Lesson 121. So all the questions I'm doing on here are from Lesson 121, just so you know. Now, what we're doing is we're talking about probability. There's two types of probability that we're going to talk about, and this is just an intro lesson. We're going to do a little bit higher level probability on next Tuesday, but this is just an intro to probability. So I have some questions for you guys. So have your chat open, and I want you just to chat me this probability question. I want you to think about an event that is certain, 100% always will happen. So text in there, chat in there, something that happens 100% of the time, never less. It's certain. Could be anything. I see Christmas. I see buying food. Anything else that you know 100%, it's certain that it's going to happen. Breathing. Thank you, Brendan. Yes. John said the same thing. Breathing. A holiday. Living. Not having school because, oh, I see. I knew I'd get somebody saying that. Existing. Thinking. Hold on. I got to admit Carson again. There we go. Anything else? So those are all 100%. So when something is 100%, that means they're 100% means they're certain. That's certain. So how about on the other end of the spectrum? So if you have 100%, 100%'s like 1 out of 1, 10 out of 10, all the time. It's for sure. Now on the other side of the spectrum or number line, think of something that is 0%. Could never, ever, ever, ever happen. Ever. Type something in the chat that you know can never happen. Not possible. Impossible. Now, some of these I don't agree with. Okay, I agree with having immortality, John. That's a good one. So impossible. I'm a little confused on some of these. Seeing a giant human, not thinking. Yeah, because your brain's always thinking of something. Anything else? Okay. Holidays more than one time a year? Well, I'd say probably at this point. Okay. So these sound pretty good. Maddie, we're talking about things. Now, when you're thinking about 100% and then 0%, when you're thinking 0%, you want to think of things that are impossible. So in other words, 0% would be the sun not coming up, would be 0%. 100% with the sun rising. So things like that are definitely, those are impossible. So when you have something impossible, that's 0 out of 100 or 0%. Or 0 out of 1. So think about, you have possible and you have impossible. In between possible and impossible, you have a middle area, something that could be 1% to 99%. So now think of something that is possible, but not certain. So something that falls between 0% and 100%. Give me something that is possible, but is not certain to happen. Okay, I saw going to school May 1st. I agree with that. Being underwater for 3 minutes. I like that, John, because that is possible, but not certain. Getting struck by lightning, yes. So we're so morbid here. Okay. True, possible, but not certain. We're not saying things that, no, Daniel, I'm not saying it. Going to school in the summer, it is possible, but not certain. So those are good. And then if you're thinking of things as far as nature or weather, you could think of it's snowing today. Oh, it happened. Or it's sleeting or hailing or tornadoes have been hitting. So things like that are possible, but not certain. So I like the things I'm seeing on there. Now, so those, anything possible but not certain. It's going to be between 1%. It's going to be 1 to 99%, somewhere in there. So let's stop texting for a second because I want a new thought now. Now I'm thinking of something. What is exactly, what falls right in the middle? What is 50%? What would fall right on the 50% of the timeline? Think about probability. 50%. Give me something that would be 50%. Miles, a coin flip. That's exactly what I was thinking of. 50% of the time, it should be heads or tails. Anything else you could think 50% of the time that would be exactly? Coin flip might be the only thing we could really think of for 50%. Okay, win or lose. Yeah, I guess you could say win or lose, but again, that depends on what you're talking about. Maybe I saw something about a time limit, like a game at the 50%, it would be halfway mark. A wheel spin with 2 sections would be 50%. That's good too. Now be careful with rock, paper, scissors, because that's a lot more variables. So there's a lot more going on for combinations. So that would be more than 50% or less than 50%. Based on what you're talking about. So that's what, when you're thinking probability, you're thinking, what is the, how often will the event occur? This is the definition for probability. It's very involved, but basically, when you're talking about probability, see how they show the capital P, and then in parentheses, you talk about the probability that you're indicating. So I'll talk more about this little formula that looks more complicated than it actually is. When you're talking probability, you're looking at the number of successful outcomes over the number of possible outcomes. So if you want to write this down, this would be a good one to write down. Just this formula here. Now they show you on the bottom that you could put things in place of the A as examples. So for example, well, if you're writing that down, I'm gonna just go over this. The probability of getting tails would be 1/2, because the number of times you see tails on a coin is 1 time. The total number of outcomes are 2. So that would be probability of tails. This is how you'd write it as a probability statement. The probability, and then parentheses, tails, is 1/2. Because there's only 1 tail on the coin, as long as it's a normal coin, and there's 2 sides to the coin, so 2 possible outcomes. So there'd be 1 out of 2. Now, if you change that to a percent, it would be 50% of the time. Now, does that always happen in an experiment that you'll have 50% of the time tails? No, we're gonna do a couple quick experiments on here too. So that's the probability formula. And it looks a lot more difficult than it is. It's just showing what the probability of an event is. And this, again, is straight from lesson 121. So if you just click on the blue probability word, you'll see that same definition there. So now, what we're gonna do is do a little, it's called Go Fish game. So I'm gonna go to the little E tool. So Mike he wants to win a stuffed animal at a carnival. So he sees that for the fish in the bag, what they did to this little magical bag, and you have this same tool in the 121 lesson, is you have a little bag. And inside this paper bag, they already put 1 green fish, 3 blue fish, and 6 yellow fish. Now, there are 2 types of probability that we can talk about, that we are gonna talk about. So write these 2 types down. I'm going to get my little writing tool out so I can show you. So there's 2 types of probability we're going to talk about today. The first type is called experimental probability. So write the word experimental, spell it right, probability. So that's the first type of probability, which is experimental probability. In experimental, and again, if there's any kind of lag or anything's freezing, I do post these on Classroom and on YouTube. So if you can't see the whole video, just again, you could rewatch it then. So experimental probability really applies to math and science. It's actually doing an experiment and recording the results, which we're gonna do in a couple minutes with this little bag of fish that look like circles and squares. And the other type of probability we're going to talk about today is theoretical probability. So theoretical probability. Now it sounds more difficult than it is. Theoretical probability is basically what should happen. So theoretical probability is a set probability. It's what should happen if you look at the number of objects that you're dealing with. So we're going to look at theoretical probability first, and you guys are going to help me out with that in chat in a minute. And then we'll look at the experimental probability in a little experiment. We're going to do a tiny experiment with this little bag of random fish that really are just circles and squares. So the first thing though I want to talk about is theoretical probability. So theoretical probability, what should happen when given a set of data. So theoretical probability is what should happen when given a set of data. So that's the very basic definition of what theoretical probability is. Now, could I make that more complicated? Yes. Does your book make that more complicated? Yes. But that's basically what it is. Now, what we're going to do is find the theoretical probability if they're at a carnival and they have a paper bag or a pond with a bunch of fish, and they have to catch the little magnetic fish like a carnival. And basically, if they get a green fish, they get the best prize. If they get a blue fish, they get the medium-sized prize. And if they get the yellow fish, then they get the small prize. So this is what you have in the bag. Now, don't worry about the size of the blocks. Just imagine the yellow is just the same size as the green and purple. So imagine they're all the same sizes, because I know how your minds are thinking. You're thinking, well, they're different sizes. So that should matter. Imagine that they're all the same rectangles or squares. So if I'm thinking probability, think of the fractional amount. So think about somebody text in there, type in there, what is the probability, if I think theoretical probability as the amount of possible outcomes that would be this color over the total outcome. So what would be the fractional theoretical probability for getting a green fish? So either tell me as a fraction or a percent. Just ignore Tommy's, type your own. I'm not telling Tommy if he's right or wrong. Just type for a green fish, fraction or percent of time you should get a green fish. Now I sort of like that I'm getting different answers, because I can then make sure I clarify what you guys are thinking incorrectly. Now I had some people say 10%, some people said 33%, some people said 30%. So everybody type, how many times can you get a green fish? Type in the number of times you can get a green fish. A lot. No, Carson. 1. If you look at the amount of fish that are here, it says 1 green fish, 3 blue fish, 6 yellow fish. So you could get 1 green fish. Type how many times you could possibly get a blue fish in this bag. 3. There we go. Type how many times you could get a yellow fish. 6 is correct. So how many total possibilities are there if you have the green, blue, and yellow in one bag? How many total fish are in the bag? 10. Good. There's 10 total fish in the bag. There's not 3 fish. There's 1 green, 3 blue, and 6 yellow. That makes 10 fish. So now tell me, what percentage of the time or what fraction of the time will you get a green fish? Percent or fraction are fine. There we go. I see 1/10 of the time or 10% of the time. Good. So the theoretical probability is what should happen. Should happen. So I'm just going to type for our little, if it lets me, hold on. letting me copy again. So what I'm going to do is just, I'm going to type on here, this is what should happen, is that for green, it should be 1/10 of a time. So that's the theoretical probability. So 1/10 or 10%. So you could type either one. How about for blue? Type what blue? What percent or what fractional amount of time would be blue? I see 3/10, 30%. Yep, 30% or 3/10. And then finally, yellow would be what? 6 out of 10 or 60% is correct. So now all of these numbers are theoretical probability. That's what should happen. Now, how can you write that as a theoretical probability statement? Well, you just have to, and you'll see this in the book. So on your homework, when you see this, I don't want you to feel like you don't understand what they're doing. You would write capital P, and then if they're doing the probability of green, so say they said, what's the probability of getting a green fish? This is what they're going to show you in your book. Capital P means probability. In parentheses, they put the color they want, or they could say green fish. So your answer would just be 1/10 or 10%. So when you see questions like that on the homework, just realize that's how it's set up. When they have probability statements, they put the capital P, they put what they're looking for in parentheses, and then you just have to answer it as a percent or a fraction, whichever one is easier or makes sense to you. These are easy as fractions because they're over 10. So now, that's theoretical probability. Any questions on theoretical probability? Because then we're going to do experimental. Questions? No, okay. So theoretical, in theory, it's like theory, scientific theories. That's what should happen. When scientists do experiments, they're testing the theoretical probability. They're seeing if it really holds true. So now we're going to talk about the experimental probability. Now, experimental probability is different because experimental probability, I'm going to put a quick definition, what actually happens in an experiment. So experimental probability is what actually happens in an experiment. So basically what they do is they'll do an experiment and they'll see what actually happens. Now, when they're doing an experiment, they're going to do an experiment a lot more times than I'm going to do. If they're testing, say they're testing a new product for safety, sort of like even they're testing vaccines and things like that right now, they're not going to do the experiment one time and then say, oh, it worked, it must be safe, or 2 times, or 10 times. How many times do you think they do an experiment if they're really checking safety or seeing if something's true? What's a good number of times to repeat something? 100 times? 101? I would say any experiment that's done. Now, if it's a lab experiment for something they're trying to test for human safety, they're going to do this 1,000 times. They're not going to do it 10, 20. They're going to do this over and over again so they could prove that it's safe. Now, for something like this, say for a coin flip, say if we did a coin and we tried to see how many times where they would see how many times that the coin would be heads or tails. Now, if you just flip that coin 10 times, it could be tails 10 times. Does that mean the probability of getting tails is 100%? No. It's just luck of the draw. It's just the way it happened. So again, what they're going to do, if you flip a coin, and if we were in school, this is what we would be doing. We would all flip our own coin. We'd all flip our own coin at least probably 100 times each and keep track of the data. If you look at the data, and trust me, I've done this many, many years with my honors classes. If you look at the data of a whole class of 24 people flipping a coin 100 times, how many flips is that, guys? How many coin flips is that if you flip your own coin 100 times? And you have 24 people in the class. Oh, quick math, 2,400 times, yes. That's a lot of coin flips. So if you do that, you're going to see that it will be very close to 50%. Usually when I do that in class, it's about 49% to 51%, it's heads or tails. So that's what you have to do on a real experiment to get good results. Now we're just going to test this with a little paper bag. Again, in this paper bag, you can't see them, but they already added 1 green fish, 3 blue fish, and 6 yellow fish. So we're gonna collect the data and then we're going to analyze it. So I'm gonna do green, and you can keep track of this on your paper if you want, blue, and then I'm going to have my yellow fish, and we're gonna see the experimental probability, and you have the same tool in your lesson for 1-2-1. So when you're done, you could test, you could do this millions of times, but I'm just going to do this 10 times. Now 10 times is usually not good because it's not gonna show great data. It might be exactly what we found theoretically, but we're just gonna try the experiment with just 10 total times. So I'm gonna shake the bag and we're gonna see what we get. Oh, blue. So we're gonna put a tally mark next to blue. So that's 1 blue. Yellow. So now I'm putting a tally mark by yellow. So I've done 2 out of 10. Blue again. I'm just gonna change it to 2. Yellow again. Yellow again. Yellow again. We have 4 more. Blue again. Blue again. 2 more. Blue again. Blue again. So now, see what I did there? I just did an experiment, and I just did that experiment 10 times. Just like a carnival game, if you are doing a carnival game, the chances of getting the one that there's only one of is only 10% of the time. Now, it is interesting with our data, if we change this to the experimental probability, what would be the percent of times that we got green? Obviously, what? We have no, well, we didn't get green at all. When I did the experiment, we didn't get green at all. So green would be 0% or 0 out of 10 times. Okay. Blue, if I change this to a fractional probability, it would be what? 60% or 6 out of 10, there we go. And then yellow. I see 40% people are saying, or 4 out of 10. So that's what actually happened when you do an experiment. So experimental probability is what actually happened. Theoretical is what should happen. So you see they do differ. And if we do this 100 times or so, obviously our results would change. So you want me to see how long it takes to get a green? Okay, I'm not doing this forever though. Oh, there he is. There's the green. So there was a green in there. It's just, again, if it's only 10% of the time, it's not going to come up as often as the other colors will. And it was interesting to see when you do an experiment, look at, we had more blue than yellows, even though theoretically we should have had more yellows than blues. So in an experiment, anything could happen. But if we did this experiment 100 times or 1,000 times, and go ahead and do that if you get bored, you will see that the probability would be extremely close to the actual theoretical probability. So that's really what you want to think about when you're thinking about probability. In theory, what should happen, that's theoretical. And experimental is what does happen when you do the experiment. Now I'm going to do one more here, and this is with a spinner. And they do have this spinner on your in this lesson again. So if you want to do that in the lesson, you can. This is about spinners, theory versus reality, part 1. So what I want you to do on your paper, because you're going to lose this as soon as I change the page, just write down the things they tell us about how we're going to make our spinner. Okay, I'll answer your question in a second. 40% should be red, 30% should be blue, 1/10 should be yellow, and the rest should be green. So just write those things down because I'm going to go to the actual spinner. And I have this on my paper too, so if you don't get a chance, but 40% should be red, 30% blue, 1/10 should be yellow, the rest should be green. Now, why did blue, and Tommy pretty much answered your question, Kay, but why did blue come up more? Why did blue come up more than yellow? It's just luck. It is. It's just in its experiment, just like flipping a coin. You could get tails 10 times in a row and not get one time heads. So it's just, that's what experiments do. They prove the data if you do an experiment hundreds of times, but if you only do it 10 times, the results probably won't match as well. Now, let me go to my spinner, and you'll see my spinner isn't right yet. My spinner should be this. Let me see if I'm gonna put this down here. So they want my spinner to be 40% red, 30% blue, I'm sorry, 30% yellow, 1/10 blue, and then we have to figure out green. So the first thing I'm going to do on the spinner is I am going to fix what I can fix. So how many sections should I make my spinner have so I could easily show these percentages? What's an easy denominator to have? 10. 4, not 4, not 4. Careful, guys. 10, 10. And I saw some people put 4 or 3. Now you can't just have 4 sections because now in the end, will I sort of, you'll see 4 colors on here, yes, but the percents are different for each color. So having 10 sections will easily have me be able to do this. So if 40% should be red, if I have 10 sections on here, see, I press down to get the sections changed. So how many of these should be red if 40% is red? 4, good. So I'm gonna keep 4 red, and they already did that. So I'm gonna go to the yellow. How many should be yellow? I see 3s, so I'm gonna make 3 yellow. How many should be blue? 1. Hold on. And then finally, think about, I have too much red right now. So since we know 40% should be red, 30% yellow, and 1/10 blue, how many should be green? I have way too many red right now. Everybody see that? I see 2s and 1s. Daniel, don't do that. So there should be 2, because if 40% is red, that means 4 should stay red, and then I'm gonna make 2 to be green. Now, some of you may have a question like, did I have to put the colors next to each other? No. When you check this on your own, I could have separated the 2 greens. I could have separated the reds. I obviously can't separate the blue because there's only 1 blue, but if you make your own spinner, and this is lesson 121, you just have to press down on the spinner and it gives you choices. And you can make as many sections as you want. I could have made 100, but that would be time consuming. As many sections as you want, and then it will show you what would happen. Now, if I did spread out the colors, would the probability change? Absolutely not. It will not change, because still 1/10 of the wheel is blue. I could put now that 20% or 2/10 is green. So the probability won't change as long as you have those percentages or fractional amounts. So when I spin this, basically it's saying that 40% of the time it should be red, 30% it should be yellow, and so on and so forth. So again, I'm just gonna do a short test, just 10 spins, just because of time. So I'm gonna do 10 total spins of this just to see how close we get to the actual probability. So I'm looking at red, yellow, blue, and green. How many times each color is spun. Now we'll see how close. Again, these numbers here are theoretical probability. That's in theory what should happen. These colors here are experimental probability, because I'm gonna just do the experiment and see what happens. So 1 spin, yellow, 1 yellow. 2 spins, oh, that's green. It's very close, but it's still green. 3 spins, red, yellow again, yellow again, red, yellow, 4, 5, 6, 7, 3 more, red again, and then 1 more. Oh, green. So again, we didn't get blue at all, but that's just what happens in experiments. So we had 40% of the time red, which was the actual theoretical probability, 40% yellow, which was a little high, 20% green, which was right on the dot, and then blue we didn't get at all. So we'll see how many times more I have to spin to get a blue. So 1, 2, oh, just 2 more times. So it didn't take too long to get that. So I had 2 more spins and then I would have got a blue. But that's pretty close to actual probability. And you could sort of do this probability on your own too and change around the wheel. You could make it as many colors as you want, change it around. You just have to click on, oh, well, I made the spinner already, so it won't let me do that. But on the tools, you can, there's lots of probability tools here. You see over on the side under probability tools, they have a spinner you can make your own bag of items. They have a dice you can make. You have a die and you could roll the dice to see the probability. They have a coin flipper, deck of cards, random number generator. So there's lots of cool different ways that you could check probability. And see, if you flip the coin, it'll show heads or tails and you just could count how many times you flip the coin. So they're sort of neat little tools to check the probability. So you can do that again under, this is lesson 121, 1-54. So I am going to go back to the room because that's pretty much the lesson. Remember, I'm going to post, and I'll come back to you guys in a minute after I'm done saying this. I'm going to post the homework. After I make this video, I have to sort of edit the video a little bit. So I'll post the homework, I'll post this video of the lesson, and I'll also post a couple helpful videos that I think will help you understand probability even more. So please feel free to go on there and look at everything. The homework is usual. It explains everything on it. It's 2 pages like usual. It's the problems. I got every single problem from this lesson. So if you want to screen capture it, just be careful to have a clear picture. Most of you, it's fine. I could zoom in pretty well, but make sure you have a clear picture when you screen capture it. Get that. Remember the multiplication and division integers homework. That is due by the end of the day today. That is due by the end of the day today. So if you submitted it while we were talking, that's fine. I will see it. I will keep checking that today. So please get that into me. This homework you're getting right now, the probability homework, isn't due until next Tuesday. So remember, being in honors, your deadlines are a little different than my other 2 classes. So just be aware, every time after a lesson, you get a new homework.